everyone, welcome to this video on covalent bonding. So there's three different types of bonding that you need to know. One of them being covalent, one of them ionic, and the other metallic bonding. And there will be another video on both of those, so go and watch them if you're not too sure on those. So covalent bonding is the sharing of electron pairs. And it's really, really important that you mention the word pairs. That is a key word. If you were just to say the sharing of electrons in your answer in the exam, you would not get the mark. You have to say sharing of electron pairs. Pairs meaning 2 or 4 or 6 or any multiple of 2. So this happens when non-metal atoms bond together. So non-metal and non-metal. This is when covalent bonding tends to happen. So let's just jump straight in. I'll give you an example. Hydrogen, H2. What you do is you're drawing the 288 rule for these elements. But with covalent bonding, you have to overlap the rings like this. So that's one hydrogen and that's the other hydrogen. So looking on the periodic table, hydrogen has 1 electron in its outer shell. In order to be stable, hydrogen needs a full outer shell. They both do. And a full outer shell in this case is 2. So what hydrogen does, this one, if I put its 1 electron in there, and for this hydrogen, it's 1 electron in there, they are now sharing this electron pair. This hydrogen has 2, and this hydrogen has 2. They're both stable. And that's all covalent bonding is, the sharing of electron pairs. Let me give you another example. H2O. So oxygen in the middle, hydrogen here, and another hydrogen there. So oxygen, again, I'm just drawing the outermost shell. I'm not going to put in all the other electrons because it just gets messy. So just the outermost electrons. And you know this by the group number on the periodic table. So oxygen is in group 6. So it's got 6 electrons in its outermost shell. Hydrogen, group 1, it has 1 electron in its outermost shell. And there's 2 of them. So what you do then is let's start drawing in hydrogen's 1 electron. It's going to go straight in the shell because that's all it's got to share. Oxygen has 6 electrons. So I'm going to draw them as dots just so you can see that they're from the oxygen as opposed to from the hydrogen. That's 4, 5, 6. Now let's count. If oxygen has hydrogen's extra electrons here, it's 1, 2, 3, 4, 5, 6, 7, 8 full outer shell. Let's check hydrogen. Hydrogen has 1, 2, this hydrogen has 1, 2. All of the elements here have a full outer shell. So covalent bonding happens in molecules. Let me just show you. There's chlorine and chlorine. They covalently bond. So my covalent bond is here. Covalent bond. So they're really strong bonds, really difficult to break. That's why covalent bonds, covalent compounds, have high melting points and boiling points. High boiling points because they require a lot of energy to break them. Between these compounds or molecules, you have something called weak intermolecular forces. These weak intermolecular forces can be easily broken. So they can be easily broken, but the covalent bonds between the elements, between the non-metal and the non-metal, cannot be easily broken. So it's really important to know about this force here. So as molecules get bigger, the strength of the intermolecular force increases, which means more energy is needed to break them, and the melting and the boiling points both increase. So depending on the group, elements either increase or decrease in size. So for instance, in group 1, the atomic radius, meaning the size of the atom, increases down the group, whereas for group 7, group 7, it's the same thing. So for all the groups, the atomic radius or the size of the atom gets bigger as you go down the group. That's because you get more and more electrons, therefore you get more and more shells or more orbitals. So the atomic radii actually increases. Therefore the intermolecular forces increase, and the melting points and the boiling points also increase. Again, there are no free electrons here, so these covalent compounds can't conduct electricity or heat because there are no delocalized electrons. So one thing you need to know about covalent bonding is they create something called giant covalent structures. And there's 3 in particular that you need to know about. There's diamond, there's graphite, and there's silicon dioxide. So diamond has a really rigid structure. If I just briefly, I'm just going to try and sketch it for you. Something like this. Really, really rigid structure. Oh, I don't think I'm doing a good job here. You just need to just see that it's just a rigid structure, and all of these here are carbon atoms. So diamond is made out of carbon. These are also known as allotropes of carbon, and allotropes just mean different versions of carbon. So carbon taking different forms via their structures. So this one is diamond. You need to know the properties. So diamond is very strong, and that's because of this rigid structure, the covalent bonding between these carbon atoms. So very strong, high melting and boiling points, again because a lot of energy is needed to break these bonds. Very strong, high melting and boiling points, don't conduct electricity. It's really important to know that each carbon atom forms 4 covalent bonds to form this giant covalent structure. So key point here, each carbon atom, so that meaning this one, forms 4 other covalent bonds. So there's 1, there's 2, there's 3, and there's 4. So, and that's the case with diamond only. So if I now show you graphite. So graphite, you've got hexagons. So 1, 2, 3, 4, 5, 6. And you've just got these layers of hexagons. Something like this. Try that again. Joined up just these hexagons like that. Okay, so this is graphite. So it's what you get in pencils. and it comes off on your page. And the reason why graphite is so soft and slippery is because of these layers. The layers can slide over each other, and that's why you get the marks on your page. So each carbon atom forms 3 covalent bonds, each to form hexagonal rings. So again, diamond had 4, but graphite has 3. The 4th electron, or the 4th carbon bond, is actually in the form of delocalized electrons around the structure. And if there are delocalized electrons, that means these electrons are free to move. So delocalized electrons. These are what carry charge and heat. So that means graphite can conduct electricity because it's these delocalized electrons that are free to move and carry the charge. So that's really important. That's one main difference between diamond and graphite. Okay, last one then. So silicon dioxide has exactly the same structure as diamond. However, this time, if I just get a different colour, it's made out of oxygen and silicon. So we get something that looks like this. And we just have silicon and oxygen bonded together. So let's just call the red, let's just call the red silicon, and let's call the blue oxygen. So again, you've got that same structure as diamond, and that's why silicon dioxide is very strong, rigid, again is a giant covalent structure. So only difference, not carbon, it's made of silicon and oxygen.